Hi everyone, this is Real World Audio, and I'm going to take you on a journey to look at single driver loudspeakers. And single driver loudspeakers, they really began with Paul Voigt at the beginning of audio, basically. So Paul Voigt, he was one of the first loudspeaker designers, or we could call him the first loudspeaker designer. He was British, and actually he also invented the electrodynamic driver, but by the time he was ready to patent it, Rice and Kellogg's already patented theirs in the US. So he did not go down in history as the inventor of the electrodynamic driver. If you are wondering, most loudspeakers today use that technology. Uh, so if you have a traditional loudspeaker with a cone in it and driven by a magnet and a voice coil, that's what I'm talking about. So he came up with that idea apart from Rice and Kellogg. And he also came up with tons of ideas. Basically, he was the first one to build the very first horn loudspeakers, and he formulated loudspeaker concepts. One of them is the famous Voigt pipe, and for the Voigt pipe he designed the very first high sensitivity, high efficiency driver. So he pioneered that technology as well. And he has like tons of patents to his name, and basically I would say like half of our concepts and ideas that we use today to create loudspeakers come from him. So here I'm going to show you a video of how a folded pipe is done. This is a video from Yamanaka Shujiro's YouTube channel, and he shows a beautiful example how he is making a folded void pipe. So let's get on with it, let's see how it's done, and I'm just going to narrate it for you. So basically this is how they look. It was just a second that you saw it. So basically on the outside they look like a tall floor standard speaker. Well, not that tall, maybe about 3-4 feet high, or actually you can make them taller if you want to, but typically that's the size range, so about 1 meter tall. And usually they are made with a relatively narrow face, which is about 8 inches or 20 centimeters, something around that size, as you see there. And let's see, let's just hurry this up a little bit. So he just shows like beautiful skills, woodworking skills, just really fantastic. So there, that's the port opening at the bottom. And but the void pipe ports work very different from typical base reflex cabinet ports. And as you see here, he uses pine wood, pine for the cabinet material, which is vastly superior to that lousy MDF. And actually, guys, tell you something, that pine, that's the closest wood to spruce. And why is that so important? Because spruce is the wood that is being used as the most coveted tone wood for building guitars, violins, pianos. So the soundboard of the piano is made of spruce. And not just any spruce, but tone wood grade spruce. So if you want to make a loudspeaker, build it from tone wood grade spruce. And I let you in a secret, it will cost you an arm and a leg and maybe more. So imagine just a little violin from such tone wood grade spruce, it costs like it has like an orbital price. Now imagine getting that much spruce for a speaker cabinet. That would be also in the price of a down payment or maybe a car. So unfortunately we cannot really go to that length, but maybe you might just luck out and you can source some spruce for your cabinets. A good friend of mine did build his void pipes. I designed those pipes for him, and he managed to build that from spruce. It was one of the best sounding loudspeakers I ever had the fortune to listen to. It was truly fantastic, and the experience is more like listening to a music instrument rather than listening to a clinical sounding stereo, which is not such a good idea in my eyes. Of course, a clinical sounding system can give lot of pleasure, lot of joy to many, but I suspect that you are watching my channel because you are not exactly looking forward to that sort of sound with like a showy, over-controlled, over-dampened, everything sounds like a studio recording, squeaky clean, really artificial, not a human touch in it, so that type of sound. So if you want to avoid that, then go for spruce, and if you cannot find it or cannot afford it, then go for pine wood. So in the meanwhile, he has been assembling his speakers, and let's just maybe pause it at this moment. Perfect. So how do these void pipe work? So there he is placing the driver cone there, so it will radiate outside, and the back pressure is going to come through here in this resonant cavity up here, and that cavity continues and expands out to a really wide base. So you see, basically this cabinet internally is a large triangle, a large wedge, and the top of the triangle is being folded down onto the front. You see, that's why it's called a folded void pipe, because it's basically a standing void pipe, which would be that big triangle wedge with the driver cone in the middle, and the slot port, I would say not slot port, but the port facing forward. However, here the port itself is not a tuned port, but it's rather a larger opening, and its purpose is not to give a tuning frequency to your cabinet. And that's because in the cabinet there's a quarter wave forming, or I would say not just quarter wave, all kinds of waves which are up to the length of this length. So like this part plus that part. So effectively almost twice the height of your cabinet. And that's the 4 times that wavelength is the wavelength that this cabinet can support. So these void pipes use a resonant air column to create the back pressure, to create the bass response. So in a bass reflex cabinet is just the internal pressure that wants to escape through the port, and by choosing the diameter and the length of the port, you are tuning the frequency at which that pressure can escape from your cabinet. So basically, in a bass reflex situation, your cabinet is pressurized. Here there is no pressurization. Instead, your cabinet acts as a resonant cavity, and this resonant cavity will first resonate the air with the back pressure that's coming from the driver, and this is going to couple with your room, with the air of your room through the slot port. And this is a very effective, very efficient method, because the port is a pretty big one, the opening is quite big, and the coupling between the inside and the air is not choked down. So in a typical bass reflex cabinet, the port chokes down the communication between the inside and the outside, and the inside is pressurized. So in a void pipe situation or a folded pipe, the inside is not pressurized. Usually for the front part, the narrower cavity, people put in some filling material. When I built my void pipe, I did the same thing, and depending on how much fill you put in there, you can tune the sound of your pipe. If you put in less, then the response will be like higher tonality. You will hear bass that doesn't seem to reach as low, but it's much faster. And also your mid-range and the entire response of your speaker, if you do not have any fill here, is just lightning fast. The more you start to fill it up, the better the deep bass start to become, but at the same time you are losing that sudden impact, that speed as well. So let's see, what is he doing? So you see he's using wood glue, tight bond. That's the glue that we use to glue together flooring or any kind of wood, and it creates a natural connection between the two wooden pieces, and when it dries as if it was part of the wood itself. So basically he's making like a fully sealed cabinet without any way of taking it apart. So how I built my void pipe, instead of glue, I used screws to hold the sides together, and that gives you an opportunity that you can take it apart if you want to for modifications. Another alternative is that if you do not have this many tools to tighten it together, because if you fasten them up, then it dries with a much greater strength. Then you can also like use the wood glue and then add screws on the side, and that will hold it and make it a very strong connection. And now he just adds, I think maybe he's sanding, and then he adds linseed oil, I think. He used the router to trim down the corners, the edges, because for the sound it's not a good idea to have like a really sharp break at any point. You want to round down everything. Like you see, he's rounding down even the sides. You want to do that, because if you have like a sharp corner, then there will be edge diffraction on it. So basically the sound waves will be bouncing at a sharp angle. So if you have a nice round side, that's going to get rid of a lot of the artifacts that create sharpness in the sound and some annoying characteristics to your loudspeaker. So now his finishes up, he adds some extra sanding, and he sands it lightly, and he adds, maybe it looks like it could be shellac or linseed oil, maybe it's shellac. With varnish, actually, when I built my void pipe, I also used shellac, but and then you read that some people do like add like heavier layers of paints or varnish, or maybe like add a veneer, and especially adding a veneer is something that should be avoidable at all costs, because even adding paint is really bad. When you do that, you are going to change the resonant characteristics of your wood, and if you are using pine wood, then adding any kind of paint on it or varnish, or even adding that really ugly veneer on top, which makes it looks really pretty, but it fakes as if it was made of some other exotic wood, but it's really some really junk plastic that you add. So it's kind of like covering up your violin in a plastic bag. It's really god awful. you should avoid that. So what I can recommend after 20 years of building loudspeakers is avoid using anything on your loudspeaker. Maybe you can add some linseed oil, maybe you can add some shellac, but be very light and gentle with it, or maybe beeswax, because if you add any paint, it's going to deaden the sound. Yes, it will take you closer to the camp of show sound. So when you want your sound to be controlled and mechanical and artificial, then it will take you definitively towards that direction. But if you want to hear violin, if you want to hear a concert piano, then that will ruin your experience a lot. Also, for example, guitar or human voice, it's going to take away about 30% of the sound or maybe more. So what I recommend to do is just sand down the surface. So what I did with my Altec speakers, I sanded them down, going higher and higher grits, and I finished with a 2000 grit on the face, and it's just absolutely gorgeous. So here he's mounting the driver, and there it is. That's how they look like when they are built, and they have to be standing on the floor, because if you when it's on the floor, then you get the floor boost for the bass, so that's 6 extra dB that you gain for the efficiency for the bass output. And the lowest frequencies are governed by the height of your loudspeaker and not by the size of your driver. The size of your driver will limit you the efficiency of these speakers, and it will also limit you the top SPL that they are capable to do. But the bass itself will be defined by the height. So if you want them to reach deeper, make them taller. But also that will demand higher excursion from the driver, so you will reach a point where these tiny drivers will not be of use for you. So that's my introduction video on folded void pipes. It's also called a TQWP, which means like a quarter wave folded pipe. And this is Paul Voigt's invention. He created this system, and I can recommend it as a very easy build. You did see how it is done. You can recreate it. The exact dimensions are not really critical. You can get any single driver loudspeaker and put it in one of these cabinets. The only thing for cabinet design is look at the free air volume requirement, the VAS of the loudspeaker in the datasheet, and make your cabinet be close to that value. So do not make it too much larger or too much smaller than that value, because then you are going to have problems with it. And this is the type of loudspeaker that I warmly recommend for a low power single-ended triode amplifier, such as the one that we are building now, that Darling amplifier. So this is what I have been using, the void pipes for my Darling amplifier. I was not using the folded version, but the full height version, and you have already seen a photo of that in my Darling video. And this is the same idea, same concept, just folding the top part down, and here you have a cabinet that looks like a regular floor stander, but it's very far from that. It's a void pipe. Thank you for tuning in. Please like and subscribe. Bye bye.